Well, tip top of the day to you. Not sure if you're watching this in the middle of the night because you're wanting to get homework done or right before class in the early depths of the morning, but I welcome you, whatever time of day, and I hope you are well inside. So we're going to get back into slope and really define slope a lot better than we have. So if you're not quite sure what's been going on, hopefully after this video you'll have a bit better of an idea of what slope is. So on your notes, I'm going to have you write down some stuff in just a moment. So you see right in front of you the key idea that the slope of a line is the ratio of the change in y, or the rise as they call it, to the change in x, and that's the run. So a few things is, instead of writing all those words, let's instead write this equation that they give you right in the middle of the screen. So slope equals, and you have change in y, you can even do a little triangle if you want since we know what that means, and change in x, and that equals the rise over the run. So if you take a look to this little thing that they drew here, you'll see that they labeled this blue as run and this red as rise. So run is a good way to think of things that go horizontal, like running. You run on like a track, back and forth. And that's along the x. And then rise is, of course, going up or down, like a hot air balloon or something like that. So this idea of slope is always your rise over your run. I like to think it run would be on the bottom. So like, I don't know, on the bottom part, and rise would go up. So it's like saying run down here and rise up here. So think of a way for you to remember rise over run. And I always like to start with the x value first whenever I use any slope, but we'll get to that. So that's the run, and the rise is on the top, run's on the bottom. So once we have this equation written down, I want you to quickly jot down what a positive and what a negative slope would look like. So you have here this quick little xy axis. I mean, even if I were to do this again, xy, and let's label it x and y, and a positive slope would be anything that's going whoosh, up from left to right. Because that's the way we read from left to right, so it's something that's going up. Negative slope from left to right is going down. It falls from left to right. So here's an example, and we are going to find a slope of the line. We're first going to tell whether the slope is going to be positive or negative, and then find it. This is a little bit of review of what we did in our RAP journals. So take a look. First, we got to see if it's positive or negative. It's always the first place to look. Now, you ask yourself, is this line going up from left to right? Is it going up? Yeah. So A, we know is going to be positive. Woohoo! And then B, we see it's going down from left to right. So B, we know is going to be negative. Now let's actually find the slope. So we have a change in the rise as 6, and we have a change in the y as 5. Ta-da! Can't simplify that. 5 over 6 is your slope. Or we have in B, the change in our x from left to right is it changes. It goes 2 over. You notice how x is always positive in these situations, but then it goes down, -3. So we have 2 for our run, -3 for our rise. And our slope then is just a -3 over 2. So you can write it like that, or you see how the book wrote it down here actually. Instead of -3 right next to it, it actually looks like the negative right there next to the whole problem itself. So that's the same thing. Even if we had something like 3 over -2, that would still look like -3 over 2. We know the whole thing is going to be negative, so you can just write the negative on the outside there. One more example before you guys can go ahead and do some on your owns is finding the slope of a horizontal line. Here's one more thing we can add to our slope notes. Is we had a little coordinate plane, x, y. We know this was positive, y. And we had another little coordinate plane that was showing a negative line. So that's a positive line. And this line is a negative line. And then if we have a horizontal line, the slope is neither positive or negative, but the slope is 0. That's essentially what's going on here. Slope of a horizontal line is always 0. If you guys see that. And if you look at it here, if we were to look at its rise and its run, this line, it's running from these 2 points over 1, 2, 3, 4, 5, 6, 7, but it does not rise at all. So 0 divided by 7, or 0 divided by any number, is just 0. So your slope is just, if you look in on your owns, you'll notice that, ooh, Lacey's texting. Not sure where I left off. Let's look at our own examples. For our first example here, it's pretty easy. All we just require some counting. So let's go 1, 2, 3, 4, 5. So it goes over 5, and it goes down 1, or -1. So let's put our change in y over our change in x. It changes in y, -1, and it changes in x, a total of 5. That, simplified, really just looks like -1/5. So you can even say slope equals -1/5. For 2, if you should see that, oh, does it go up or down at all? Is there even any slope, or is it just a flat horizontal line? If it's a flat horizontal line, you should look up there, and that tells you what the slope is. And number 3, let's go ahead and do some counting. Let's go over 1, 2, and then let's go up 1, 2, 3, 4, 5. So we have our change in y is 5, and our change in x is 2. The slope is positive. I can't simplify that fraction. You can write it as a mixed number, but I would get used to keeping slopes as a fraction, so it's easier to see the run and the rise. As opposed to a mixed number, then you'd have to convert it to an improper fraction anyway. 2 more examples, then we're done. You'll see here that they ask you to find the slope from a table. So someone has been nice enough to already make a table. They didn't even give us the equation, and plugged in some numbers. I want to see if you notice a pattern here. For the x, when x is 1, y is 8. When x is 4, y is 6. When x is 7, y is 4. When x is 10, y is 2. Now I want you to see what's happening to the y value. It looks like it's going down. Ooh, that sounds like our line is going to be negative. And I want you to look at a pattern too between these and see if you can find it. This, you add 3 each time, is the change, plus 3, plus 3. Down here, it looks like you're subtracting 2, subtract 2, subtract 2. Now let's look at the graph and see if it's consistent. It looks like, oh, every time they went over 3, down 2, over 3, down 2, over 3, down 2, and instead of doing a bunch of math and an equation, they just used a graph to find those points. Bing, bang, boom, boom, boom. So let's use these points to actually find our slope. And you can choose any 2 points, any at all. It's free and freedom. So it's best to choose points close together, because then you won't have to simplify a fraction, because who likes to simplify fractions? So they went ahead and chose some points. They chose 1, 8, and 4, 6. And if you see here, it's the first 2 points. So the change in y, they counted over, or sorry, they counted down. 1, 2, it's -2. And the change in x, 1, 2, 3. They could have used their graph, but actually they just took these points and they found the difference between the 2 points. So in order to find the difference, they subtracted the first point from the second point. So here's your 6, 4. So here's your y2, that second point. Here's your second little x. In the first one, there's the first y coordinate of the first one. Here's the x coordinate of the first one. You guys see that, how these are related? And then 8 comes from here, and so on. They did the math, and 6 minus 8 is -2, 4 minus 1 is 3, and so that gives us a slope of -2/3. Here's some on your owns that are pretty easy. They say the points on the table, so that means these tables that they made for you, lie on a line. Find the slope of the line, and then draw its graph. So let's see how much each one changes. This one looks like you add 2, each time. Plus 2, plus 2, plus 2. This one looks like u plus 3, plus 3, plus 3. So I would say that the change in x would, I'm not going to write it right next to it. I would say that the change in x, or the run, is 2, and the change in y would be 3. Positive. And then you can go ahead, actually, if you're listening to the video still, don't graph that, because if you can get the slope here, you don't really need to graph it. You know that it's positive, it's going up. If you would like to graph it, by all means, if it makes it make more sense for you. So here you'll notice the change is just adding 1 each time. Down here you'll notice it's just subtracting 2 each time. So if we were to get the slope, it'd be the change in y over the change in x. And simplified, that just looks like -2. Again, you don't need to graph that unless you really want to. Last key idea, last example of the night, last on your own. So it says here, parallel lines and slopes at the top of your page. 2 lines on the same plane that do not intersect are parallel lines. 2 lines with the same slope are parallel. So that means if 2 lines went on forever and they never touched each other, they'd be parallel, but hey, parallel lines have the same slope. I would like you guys to write down the second part of this key idea. 2 lines of the same slope are parallel. Now, using that idea, we can ask ourselves, which of these 2 lines are parallel? On the left here, you see the blue line, the red line, and the green line. So for each one, what the book did is they got their rise over their run. The blue line, it rises 4 units and runs 1 unit. The red line rises 5 units and runs 1 unit. And the green line rises 4 units and runs 1 unit. So if you see their slopes are all simplified for you, if they have the same slope, that means they will never ever find each other in Destiny. But that red line is going to meet both the blue and the green line because its slope is slightly different. Therefore, it's not parallel. So for the last on your own, if you would please find the slope of the blue line, the red line, and the green line by finding a difference of its slope. It might have the same slope. Some of them might have a different slope. So we'll see which one it is. I suggest perhaps counting like this, since they already have it graphed out on you. That'd be nice. And so on. Well, it's been a hoot and a holler. I'm going to edit this, and then we'll all be able to move on with our lives. Thank you for tuning in. I will see you when I see you.